So in this video I am going to be talking about single circulatory systems and double circulatory systems. Now before we actually dive deep into what a single circulatory system is and a double circulatory system, let's first get the definition of each one. So a single circulatory system is one in which blood passes through the heart once in one complete circuit around the body. In a double circulatory system, however, blood passes through the heart twice in one complete circuit around the body. So you can kind of get the difference. And an example of an organism that has a single circulatory system would be fish. Fish have a single circulatory system. For an organism that has a double circulatory system, us humans, we have a double circulatory system. Now, for single circulatory and double circulatory systems, we'll draw a diagram or a rough sketch of how it looks like. So over here we have the heart, and there's a blood vessel which transports it around the body, and it comes back here to the heart again. For humans, what we have is something like this, which I will talk about in a moment. So first we'll talk about this thing over here. Okay, so blood is pumped from the heart as deoxygenated blood, and it goes over here until it reaches here, the gills. So it reaches here, which are the gills. Therefore oxygen diffuses in, so oxygen comes in and the blood becomes oxygenated. There are gills also over here, but when it is oxygenated, it usually gets used up along the way, or it remain there. The oxygen content when it passes through the heart is not that high, so it's kind of low. Okay, so and the pressure of the blood being pumped is relatively low, because when blood is pumped from the heart, it isn't being pumped through a wide blood vessel, it is being pumped through a narrow blood vessel. So therefore, like, the pressure would be high in this area over here. So like the pressure of blood would be high in for a certain distance or time, and then the rest of the journey it remains low. So low pressure. Why? Because first of all, or the main reason, is because the vessels are narrow. In a human circulatory system, which is a double circulatory system, it is kind of like or I'll describe that later. First, let's describe what happens. So oxygen or deoxygenated blood comes into the heart. The heart pumps it to the lungs. So these are the lungs. In the lungs, the blood gains oxygen, and how it does is that oxygen goes into red blood cells. So oxygen moves into red blood cells, and it joins with a pigment in the red blood cells called hemoglobin. So therefore, which a small short version is HB, becomes oxyhemoglobin. Anyway, so it is pumped back to the heart, and the heart then pumps it to her. Now the pressure of the blood when it's coming back over here is low, so low pressure. When it's going to the lungs, it is high because it is just being pumped from the heart. When it is coming back to the heart, it is at a low pressure. When it is pumped from the heart, I think that is what, in my opinion, I think from what I've studied, that would be the peak of its pressure. Like, that's when it is. The reason why is not only because of the strong muscles, but also because over here you have a wide vessel, while in a fish's you have a narrow vessel. vessel. So that's one. And if you divide the systems of a double circulatory system, because you would have it something like, let me just try it once more because it's like really cramped. So here's a double circulatory system. These are to the lungs, to the body, to and back to the body. So let me just write it in yellow. So this system over here would be called the pulmonary system. Pulmonary system. The pulmonary system. This system basically is the this is a part of the circulatory system, which or it is a part of the circulatory system which which contains the blood vessels that take blood to the lungs and back. Then we have the blood vessels that take blood to the body and back, which is called the systematic system. That's a lot of S's. So systematic system. Systematic? No, sorry, systemic. I'm sorry, mistake. Systemic. Okay. Now we get to the main point, which is the the advantage. Which one is better for an organism to have? So basically, if you compare the main reason, it would be the double circulatory system. Why? Okay, as you guys know that cells, okay, let me just write this over here. Okay, let me just erase this line over here so that now we have, okay, so cells need oxygen. They need oxygen. Why? In order to respire. That's one of the main reasons why they need oxygen. Now let's say that the single circulatory system, okay, or let's say that a fish is let's say is moving really fast, okay, so that means that its muscle cells will need more oxygen, because oxygen, so they will need more oxygen, as oxygen used is going up, so therefore they'll need more oxygen. Now the problem with this is the narrow vessels which they have. When the blood is being pumped, or when blood is being pumped from the heart, it is at a high pressure for a small amount of time, and then it travels at a slower rate if you compare it to a double circulatory system. In a double circulatory system, what happens? Again, muscle cells, let's say you are exercising, muscle cells need oxygen. They need more oxygen, because oxygen used, the amount of oxygen being used is also high. Therefore, both of these organisms need more oxygen. However, the difference is that oxygen, well, or when a human gains, or when a human's blood becomes oxygenated, it is not it does not just travel around without being re-pumped by the heart like a fish. It travels back to the heart, and the heart pumps it even at a higher pressure. Therefore, muscle cells get the required oxygen. However, for a fish, when blood is oxygenated, it is at a low pressure. Therefore, blood moves at a slower rate to the muscle cells which need it. So that was it. That just quickly write that, or just review that. Blood is slower. Blood was slower. Here is slower. Blood is at a faster, moves at a faster rate. And over here, oxygen requirements are met at very slowly, while here oxygen requirements are met really fast or are fully met. So I hope you guys enjoyed this video. Please do like, share, subscribe, and comment.